So in this video, I'm going to go through some examples of functions being evaluated recursively. Feel free to stop the video and try them on your own before I go through them. So for the first function, the a function, we're supposed to evaluate if the input is 0, and this says that that's the base case, and it just returns the value 0. When the input is 1, well, that's going to not hit the base case, and it's supposed to return our input, 1, plus the function again at 1 less than the input. And we know that a of 0 was 0, so this is just 1 plus 0, which is 1. For a of 2, it's going to do the exact same thing, 2 plus a of 1, right? 1 less than the current input. We knew that a of 1 was 1, so 2 plus 1 is 3. A of 3 is going to be our current input, 3, plus a of 1 less than our current input. And remember that a of 2 was 3, so this is 3 plus 3, which is 6. A of 4 is going to be 4 plus a of 1 less than our current input. And we knew that a of 3 was 6, so 4 plus 6 is 10. And if you're following what's happening here, what this function is doing is it's the sum of the whole numbers from 1 to n. So like for the number 4, 1 to 4, if you add them up, 1 plus 2 plus 3 plus 4 is 10. The mind-melting way to think about this function is if you want to add up all the numbers from 1 to n, what you do is you take the last number and then add to that the sum of all the numbers from 1 to n minus 1. If that made sense, that's great. Otherwise, that's an idea that takes a long time to really click. So once again, if you want to add up all the numbers, this isn't the name of the function, but the sum of all the numbers from 1 to, let's say, 10, is the same as 10 plus the sum of all the numbers from 1 to 9. That's essentially what this recursive function is doing, is defining a way to add up a bunch of numbers without using a loop. Let's do the same thing with the b function. For b of 0, we can see that that inputs the base case and gives us 1. For b of 1, that's going to return our input 1 times b of the one before it, so b of 0 is 1, 1 times 1 is 1. B of 2 is 2 times the function call on the input 1 less than 2. B of 1 is 1, so 2 times 1 is 2. B of 3 is 3, our input 3, times B of 1 less than 3. B of 2 is 2, so 3 times 2 is 6. B of 4 is going to be 4 times B of 1 less than our current input. B of 3 is 6, so 4 times 6 is 24. And B of 5 is going to be 5 times B of the input before, so that's 4. And B of 4 is 24. 24 times 5 is 120. And some of you might recognize that what this is doing is a factorial. And the way this definition works is if you want to do the factorial, or the product, let me write it that way. If you want to do the product of all the numbers from 1 to n, that's the same as n times the product of all the numbers from 1 to n minus 1. That's essentially what this function is doing. I do notice I missed a of negative 1 up here, so let me go back and do that one. A of negative 1 is going to give us a lot of different things. You could say that's infinite recursion. I'm going to write that it's a stack overflow exception, and SOE. Essentially, this just means that it is going to crash because it misses the base case, right? It starts at negative 1, and it's going to keep calling the function with numbers that are smaller and smaller, but it's not going to be reaching 0. So that was bad. For the C function, let's see if we can evaluate this. It says what's C of 3 is 0, so we've got two inputs. A is 3, B is 0. Because B is 0, it does not do the if case. Instead, it just returns A, and A's value is 3. The same thing happens for C of 4 is 0, because B is still 0. It's not 0. So it's going to return 4. It gets a little bit more interesting when we do C of 3, 1, because in that case, B is not equal to 0, and we're going to return our A value plus C of the same A value, but one smaller in the B department, right? So our B has gone from being a 3 to being, B gone from being a 1 to being a 0. We know what C of 3, 0 is. It's just 3, and 3 plus 3 is 6. If we did C of 3, 2, well, once again, that's not going to hit this. It's going to hit the if case. B is not 0. B is 2. So it's going to return 3 plus C of, let's see, what's this going to be? It's still going to be 3. And our B is going to be 1 less, so not going to be 2 anymore. It's going to be 1. And we know what C of 3, 1 is. It's 6. So this is going to be 3 plus 6, which is 9. C of 3, 3, if you're catching the pattern here, is going to be 3 plus C of 3, 2. And C of 3, 2 we already know is 9. 9 plus 3 is 12. So let's try C of 4, 2. This time we're not going to have the base case handy. It's going to be 4 plus C of 4, 1, which we don't know. But C of 4, 1 is going to be 4 plus C of 4, 0. And C of 4, 0 is just going to be 4. So it's going to be 4 plus 4 plus 4, which turns out to be the answer, 12. This one's a little bit harder to explain what it's doing. It's essentially trying to add up a bunch of A's. So like, it's sort of off by 1, which is sort of weird that I set it up this way. This is just sort of a weird one. Weird. Is that how you spell weird? I'm going to put strange, since I'm blanking on how to spell the word weird. You ever have that feeling when you're about to spell something you can't remember? Thanks, Google. All right, so let's do the D function. So we put in 1 and 1. So do our inputs equal? Yeah, so we return 0. We have D of 2, 2 I can do as well, because when the inputs are equal, it just returns 0. So let's do what happens when they're not equal. So D of 1, 2, when they're not equal, returns 1 plus D of, well, increase the A by 1. So now this is going to be from 2 to 2. And remember that D of 2 to 2 was 0, so 1 plus 0 is 1. D of 2 to 3 is going to do something very similar. It's going to be 1 plus D of 3, 3. And we know what D of 3, 3 is going to be because that's when the two inputs are the same. So this will be 1 plus 0, which is 1 still. D of 1, 3 is going to be 1 plus D of 2, 3. And we already know that D of 2, 3 is 1, so this is 1 plus 1, which is 2. D of 2, 4 is 1 plus D of 3, 4. Now we don't know what D of 3, 4 is, so we're going to have to figure that out. D of 3, 4, see if I can make this fit in here, I'm probably going to run out of room. D of 3, 4, that's going to be 1 plus D of 4, 4. And we know that D of 4, 4 is just going to be the number 0, so it's going to be 1 plus 1, which is the number 2. So at this point you might be realizing what this is doing. It's doing in a very strange way subtraction. Or how much do you have to add to go from the bottom number to the top number? So D of 1, 4 is going to turn out to be 3, and the same as D of 2, 5. So this is a counting technique using recursion. How do you count the number of numbers you have to increase to get from A to B? Because when you get them to match, you return 0, and until you get them to match, you're going to keep adding 1 to the sum. The last one's a really funny one that if you knew what this was right away, it's pretty impressive. So if the input is B is 0, it just returns A, which is 12. If it's not, so in this case like B is 2, what it returns is the function again, so E, with the first input now being what the second input was. And then it takes the original two inputs, 12 and 2, and mods them. 12 mod 2 is 0. And based on what we just learned above, when the second input is 0, it just gives you the first input. So that's 2. So let's do the same thing for E of 12, 3. Well, that's going to be E of 3, comma, well, what's the greatest common divisor of 12 and 3? That's going to be, or sorry, what's the remainder? I said that wrong. What's the remainder when you divide 12 by 3? That's 0. And we know that when the input for the second input is 0, we just get the first input as the answer. For E of 12, 5, it's going to be E of the second input, and then whatever 12 mod 5 is. I believe the remainder there would be 2. So what's E of 5, 2? Well, that's going to be E of the second input, comma, the first input mod the second input, and 5 mod 2 is 1. All right, do it one more time. So we're going to say that this is equal to e of the second input, 1, and then 2 mod 1 is 0. And we know when the last input is 0, the answer is just the first input. For those of you with a keen eye, and like this is very keen, this is actually doing the greatest common divisor, this function here. So to find the GCD of A and B, if you go through this recursive process, it'll give you what the greatest common divisor is. Whew! That was a lot of practice with evaluating recursive functions.